will be showing you how to use prefix sum arrays, what they are, and show you an example problem. So first, what are they? A prefix sum array is simply a way of cataloging the sum of the elements in an array and how to efficiently calculate the sum of different parts of an array. So for this array, if I want to find the sum of these elements, I'd have to loop through all of them, making it an O of n in time complexity. But if I need to do this many times, this will become inefficient. So what I can do is construct a prefix sum array. What will happen here is that each of the elements in the prefix sum array will correspond to the addition of all of the previous elements. So this one will be 0, this one will be -2, this one will be -5, this one will be -1. -1 will again make it -2. Here it'll become even less. Here it'll go up again. Here it finally gets positive, and again here it goes back to -1. So here, if I want to now calculate what the sum is from here to here, all I have to do is subtract this from this. The answer to this will be -2, and if we add all these up, we can see that that is actually the answer. Again, if we want to calculate this, for example, we just subtract this from this. This will yield the result of, again, -2, and if we add these together, we can see that this is right. So now that we know what a prefix sum is, how can we use this? So one classic prefix sum problem is to find the maximum sum subarray in an array. So in this case, we have all these numbers and we'd like to find the maximum subarray. So one way to do this is that we can iterate over all of them and keep on pick an I and a j and add all the ones in between them and keep a running max and see which one is the greatest subarray. Now, this of course will work, but the naive version of this solution will be O of n cubed. But with some further optimization, we can make this n squared. This is better, but we can still make it even quicker with prefix sum arrays. So, how might we approach this? If you can see here, we have the prefix sum arrays on the bottom, and we want to find out what the maximum subarray is. So, in this case, the answer is from 5 to 4. If you add all this up, it equals 7, which is illustrated by taking this 2 and subtracting -5 from it. In the normal solution, you'd have to go through a bunch of them, but with prefix sum arrays, we can actually change the solution all the way down to O of n. So how do we do this? Well, first, as we go along, we're going to keep just an I this time, and we are going to loop over the array, keeping a running prefix sum. So as we move I to different places, we will keep a running sum. And what we'll do after that is keep a running calculation of the least. So if we are at -2 here, our only one to compare it to is 0. So then our answer will, then when we check it to our running max, we'll start it off, which starts off with int max. It will just be -2. Now as we go along, then to -5, here we'll check the least, which is now -2, and the least subarray, where the rightmost is -3, is actually just -3 itself. So how would we go about doing this? Well, here in our past our past calculated ones, we have 0 and -2. The minimum of that, which we keep track of, is -2. So if we just do -5, which is the running total, minus -2, that gets to -3, which, as we can see, is the right answer. We keep on doing this. With 4, again, it's just 4, so we update this max to 4. For -1, it's 3. -2, it's 1. -1, it's 2. And for -5, we finally get to 7. So in this case, since we're only iterating once over the list, our complexity is O of n, which is much better than before. So when can you actually use a prefix sum array in any of your algorithms? Well, if you ever have to repeatedly calculate the sums of different ranges, then it's a great idea to just, and you aren't continuously changing it, then this is a great idea. Because again, if you're continuously changing the array, that deletes the purpose of a prefix sum, because you just have to keep on recalculating it. Okay, that will be all for today. If you like this video, please like and subscribe, and I'll see you next time.